So let us consider a second order system, and let us assume that this is going to be the input. Please note that whether it is a cos or sine, it doesn't matter. Both are sinusoidal signals. The objective is to find out the steady state response. Steady state response. Please note this, that steady state response of the system for this particular sinusoidal input. So clearly, if you look at the input, the amplitude, input amplitude is 8, magnitude is 8, and its frequency is 2. So this term can be compared to omega t, cos omega t or sin omega t. So omega is equal to 2, and it is having an initial phase of 30 degree. Okay, so that is the input. Let us find out the solution. So obviously, y of t is going to be the same output, same thing as output. Only thing is amplitude is going to be modified by g of j omega, and another phase of angle of g of j omega is going to be going to get added. So omega is equal to 2 radians per second. So therefore we should calculate g of j omega. G of s is this. G of j omega is just replace s by j omega. This is what you will get. And j square is equal to minus 1. So you will get this. You can substitute the value of omega here. If you substitute, this is what you will get. Obviously, g of j omega, as I said, is going to be a complex number. We got a complex number. Now you can calculate its magnitude, the numerator magnitude simply 10 because it's only real, and here both we have got real and imaginary parts, root of a square plus b square. So together it is 1.1785. And similarly, we can find out the angle. Angle contribution by the numerator is 0 because the imaginary part is 0, and angle contribution by this is tan inverse of 6 by 6. So the total angle contribution is 0 minus tan inverse of 6 by 6, that is equal to tan inverse of 1 minus tan inverse of 1, that is nothing but minus 45 degree. So we can substitute these values, 8 into magnitude of g of j omega. You can substitute that value, cos 2t plus 30 as it is in the input. Only thing is you have to add this g of j omega. So the output is going to be this. This is a simple problem just to understand that g of j omega is a complex number and the output frequency doesn't change, how the magnitude and the phase angle changes with respect for a particular frequency.